Ladies and gentlemen, this is the ICRC World Service. We broadcast live from the riverside lawn of the DESI campus in Zeuthen at the city limits of Berlin in Germany. My name is Johannes Knapp and I am the proud chair of the local organizing committee. On behalf of the whole local organizing committee of the 37th International Cosmic Ray Conference, I extend to you a very warm welcome. When it was decided in 2017 to have the 2021 ICRC in Berlin, we, the German Astroparticle Physics community, were excited to invite you all to Berlin to enjoy a great science program and a great city. Now, in 2021, Berlin is of course still a great city and we do have a really great science program. But unfortunately, this time the ICRC is only an online conference. You are all at your homes, spread over 55 countries and 22 time zones, from New Zealand to Hawaii. So the ICRC this year is truly global. And one could rightly say the ICRC is a conference on which the sun never sets. Thanks a lot for joining us today and in the next 2 weeks at partly difficult times for those in the Far East and the Far West. Yes, we do have a great science program. We have been helped with that by very good progress during the past 2 years. There were lots of exciting new results. We found a capable science program committee that helped us to select speakers and discussion topics and the right conveners for those topics. And finally, we got many contributions from all of you, which is also an important ingredient for this conference. It is a great conference because we have a good turn-up, more than 1,700 participants, more than 1,400 contributions. We have plenary reviews, highlight talks, rapporteurs talks. We have many parallel topical discussion sessions. We cover the traditionally broad area of subtopics: cosmic ray indirect, direct, gamma ray indirect, direct, neutrinos, solar and heliospheric, and dark matter. And we have added 2 new tracks this time, namely the multi-messenger astronomy and outreach and education. We have coffee bars that are open 24 hours and 7 days a week, where you can meet and mingle, where you can talk to your colleagues or just chat to good old friends. We do have a fringe program of an industry fair, science fair, careers, diversity and sustainability, and more. There will be full proceedings. Most of them are already available online. And we have a constant manned technical support and help desk for all the questions you may have during these 2 weeks. Now, a virtual conference of that size and complexity is a challenge for organizers and participants alike. It was a first for all of us, and so be generous with us if the odd thing doesn't work as it should be, as you know it from the news or other professional outlets. We've had a good cooperation between several types of committees: the local organizing committee, the IUPAP commission, C4, the International Science Program Committee, the discussion conveners, and the technical support here in the ICRC Mission Control. In total, this amounts to about 260 persons who have helped making this conference. Here, the organizing institutes in Germany, it's 15 institutes from all over Germany, universities, research centers, Max Planck institutes, and among these institutes, we do cover all the subspecies of this cosmic ray conference. Here are the pictures of the local organizing committee. You will see many faces of people who have been active over the past years in our community. These are the ISPC chairs, International Scientific Program Committee. Each of them had a team of 7 to 8 persons to coordinate the various areas of science. Now, this conference is unique in several points. The first one is that all plenary sessions, all discussion sessions, contributions are kept in an archive. This archive is fully searchable and accessible around the clock, and it will be accessible at least until the next ICRC in 2 years' time. Proceedings are permanently available as it was in the past and indexed in all literature databases. So in sum, this is a very good online resource for research, for study, and for education. And the value of this ICRC depends now on how much time you dedicate to look at these materials, to discuss over it, and to absorb what interesting new things are there. Make the best of this ICRC. Spend time at the conference. Use the wealth of materials and discuss with students and colleagues. This ICRC does not finish on the 23rd of July. It continues for as long as you care to use this archive. Now, the second unique thing, it's probably the greenest ICRC in recent history because we used 0 air miles to participate. So that is a great thing, and surely we will be positively mentioned in the discussion around saving the planet. Now, every crisis is also a chance. That is the saying. This ICRC is online because of the crisis of Corona. The question is now, what is the chance? Well, for the future ICRCs, one has to decide. What will be the format? Will it be back to in-person conferences? Will it be a hybrid conference, or does it stay online? What about the size, the length, the format? Somebody has to decide on that. The C4 committee from IUPAP, the Japanese lock of the next conference, and you, the ICRC community. So while you are attending this conference, make notes, think of what is good about, what should be changed for the next time, and what you want. Because by the end of this conference, IUPAP will distribute a poll where all these things are asked from you. But finally, let me say, do come to Berlin soon as traveling is possible again. It's a very attractive city. Do come for a proper visit, spend here a week or more, and we would be glad to see you back. So, thank you very much for that. Now, the proper program of this opening ceremony starts, and we start with a number of official welcome addresses. And the first one of these welcome addresses is by our Federal Minister of Education and Research. It's Anja Karliczek. Welcome and thanks for addressing us.
Esteemed participants of the Cosmic Ray Conference, welcome. I could almost say welcome to Germany. I know you are joining from your desk at home, but the conference is hosted by DESY in Zeuthen. For the third time in the history of the ICRC, a German institution that organized the conference. This is a great honor for our country. People are fascinated by the universe. It is a source of inspiration for science fiction. However, while films such as Star Wars attribute the unknown to a specific force, you get to the bottom of things. Much of what we cannot see or feel can be explained by mathematics or physics or proven through our research. such as neutrino oscillation, gravitational waves, or black holes. These are topics where researchers' breakthroughs led to Nobel Prizes, and of course to further research. In 2017, more than 40 observatories trying to detect gravitational waves witnessed to 2 neutron stars merging together. Events like this also fascinate people, particularly because they can also be used to explain the origins of heavy elements such as gold. Astroparticle physics and related research areas are also drivers for specific technological innovations in our everyday life. For example, medical diagnostic devices which reduce radiation exposure to protect the patient's health. That's the kind of research people are interested in. I would therefore like to encourage you as researchers to also invest time in lectures and discussions with different audiences. Many of you are already doing this. I would like to invite you to join the initiatives of my ministry, for example, Science in Dialogue. After all, people want to understand what you are doing, what you are discovering about the origin of the universe, about cosmic rays, and about extreme states of matter. Please share your enthusiasm for science, for astroparticle physics, in particular when you talk to young people. Encourage them to become involved with the MINT subjects. And who knows, perhaps your talks on research will encourage a future Nobel laureate. The experiments in astrophysics and astroparticle physics are extremely complex. The experimental facilities are mainly planned, constructed, and operated by international consortia. They attract researchers from all nations who contribute their knowledge to the benefit of research, but also to the benefit of international exchange and cooperation. My ministry supports cooperation through numerous international agreements and networks. This includes, for example, the European Strategy Forum on Research Infrastructures, the Common European Research Area, and Horizon Europe, the EU's framework program for research and innovation. Scientists from Germany are part of this international cooperation, including DESI in Zeuthen. They often play a lead role. As a research minister, I'm proud of this. We are supporting your excellent work of varieties of ways. A key instrument is joint institutional funding by the federal government and the Länder. 4 major research organizations in Germany are benefiting in particular: Fraunhofer, the Helmholtz Association, the Leibniz Association, and the Max Planck Society. In this way, we secure basic funding for the research and innovation system, and thus basic research which plays a crucial role. Applications require basic research. My ministry, the Ministry for Education and Research, also provides funding for the construction and expansion of many large-scale scientific facilities. One example in the field of astroparticle physics is the Cherenkov telescope array. In the future, it will be the world's largest and most sensitive gamma-ray observatory. Another example is the European Spallation Source. Its intense neutron pulses will provide unique insights into matter, which also benefit applied research. And these devices are pushing the limits of what is technically feasible. They allow researchers to move beyond the thresholds of knowledge step by step. And this is truly impressive. After more than 40 years, our probes barely research the borders of our solar system. Astrophysics have traveled billions of light years, perhaps even to the very beginning of our universe. You will find out for sure. And thank you very much for your commitment. I wish you all a successful conference.
Thank you very much for these encouraging words. We move on to the next welcome address. Christian Stegmann from DESI, Director of the Astroparticle Physics Division, will speak to you now.
Thank you very much, Johannes, and a very warm welcome also from me in the name of Daisy, who is about to play an increasingly important role in astroparticle physics. And we warmly welcome you to this very special ICRC. And it's special for two reasons. So first of all, as Johannes already mentioned, it's an online conference, and it's the first time that the ICRC is online, with all disadvantages and advantages described by Johannes. But I think secondly, and this is for me most importantly, this ICRC is special because this conference documents impressively that the virus cannot stop us. We as a community around the world have continued to work. Our experiments are running, we have advanced projects, we have finished data analysis, and we have discussed remotely, but not also in small groups, about the interpretation of the data, about how to model this and how to advance our understanding, and we made big progress in astroparticle physics. And this is remarkably documented in a lot of scientific breakthroughs during the past 2 years to be presented and discussed during this conference. The agenda of the next 2 weeks has shown us that it was the right decision not to postpone the conference any further, but to hold it online, well aware that coffee breaks are missing, open discussions and presents are missing, and many more, what makes a conference a fruitful get-together. In this context, which I like to mention one group among us in particular. These are young scientists, PhDs and postdocs. For these, a conference is an important element to build networks, to get known and to exchange their ideas with others. And I'm personally very grateful to the young people for what they have done in the past months. I have experienced here at DAISY, and I'm sure many of you have experienced the same in your home institution, with what great discipline young people have helped to keep the number of infections low. But not only this. They have worked hard to make a lot of the results possible, which will be presented in the coming 2 weeks. It's now up to us all to, during online sessions, in breakout rooms, to discuss and very much appreciate the scientific results achieved in these difficult times. It's up to us to make the next two weeks a success for all of us and to celebrate what we all have achieved. And I hope, personally hope, in some years, some people will say, yes, my career really took off at the ICRC 2021. Although the conference was online only, I met the right people who gave me important advice during a session or during a breakout room and helped me further. But before finishing, a big thank you also from my side, from DAISY's side, to our Science Advisory Committee, to the local organization committee for their efforts and all the work and time they spent in setting up this conference. But very specifically, to all those people who have converted a large part of the institute here in Zeuthen into a very large but also very safe support center, our mission control center, here to serve for all of you and to make it possible for all of you to enjoy the coming 2 weeks. So I'm just looking forward to this exciting 2 weeks together with all of you, and I wish you all a good and very stimulating time here. And now I give back to Johannes. Thank you very much.
Thank you very much, Christian. We are moving on now with a welcome message by Uli Katz. He is the chair of our Committee for Astroparticle Physics in Germany. Uli, please.
Dear colleagues, it's a pleasure for me to welcome you to the International Cosmic Ray Conference 2021. My name is Uli Katz, and I am chairing the German Committee for Astroparticle Physics, also dubbed CAT. Astroparticle Physics is also the second name of the ICRC, and so Astroparticle Physics in Germany was deeply involved in preparing the program of this conference. We are very proud and grateful that so many of you have decided to register and join this conference. Let me say a few words on astroparticle physics in Germany. CAT, the committee that I just mentioned, is an elected representation of the astroparticle science community in Germany. We have thematic constituencies covering cosmic rays, gamma ray astronomy, gravitational waves, high-energy neutrino astronomy, as well as low-energy neutrino astrophysics, neutrino properties, dark matter, astroparticle theory, and nuclear astrophysics. You will realize that the utmost of these thematic constituencies overlaps with the topics of the ICRC. So in fact, we are very proud that this conference is now being held, and we have been heavily involved in preparing it. We should mention, however, that the ICRC is not equal to this topical list because it also contains solar and heliospheric physics, and because not all aspects of nuclear astrophysics are topic of the ICRC. Nevertheless, there's a large overlap. When discussing astroparticle physics in a specific country, such as Germany, we are not doing justice to the field. In fact, astroparticle physics is a global field. Our experiments and research infrastructures are distributed over the whole globe and even beyond in space. Typical examples are experiments at the South Pole or in the deep seas or the deep waters of the oceans, at remote mountains, or in deep underground laboratories. Also, the research groups are distributed over many countries in all continents. It's a truly international global network that has developed a network of collaboration and communication. And the ICRC is definitely one of the major hubs in this network. So the following 2 weeks will serve to have or to exchange news and views on astroparticle physics, maybe to come up with exciting new ideas, and of course, to meet colleagues and increase the density of this network and to make knowledge of each other and of each other's collaborations and research. We are looking forward to that. Let me follow up on the words of our minister in mentioning that astroparticle physics is not an ivory tower, but it is part of society. I think it is fair to say that most of our salaries and also most of our instruments are financed from taxpayers' money. So the question is, what do we return for that taxpayers' money? I think the answer is manifold. We fascinate people and demonstrate the relevance of science. We attract students and educate them so that they will be the key figures in further developing our countries. We develop technology that is important for science and beyond for society. And there are certainly more points that I didn't list here. I think we must be responsible also beyond science. We are part of the society, and we have the opportunity, the knowledge, and the capability to serve the society in many respects. That is about fostering careers, that is about standing in for diversity, and that is also considering and helping in sustainability. And you may realize that these topics are part of the ICRC program this year. Please have a look at the agenda, see where these events and programs are happening, and join wherever you are interested. We are looking forward to see you there. At that point, I really would like to thank all of you for joining ICRC and for your contributions, which you have prepared for presentation here and which you have written up for reference. Let's make it an exciting, memorable event. Looking forward to see you in the discussions and presentations. Thank you.
Thank you very much, Uli, for these interesting thoughts. We move on to our last welcome speaker. It is Michel Spiro, the president of the International Union of Pure and Applied Physics. This is the body that oversees and co-organizes the ICRC back since 1947. Now, unfortunately, on very short notice, Michel Spiro was not able to attend in person, so Sunil Gupta, the chair of the C4 Commission, will instead read his president's words. Please, Sunil.
Thank you, Johannes. Michel Spiro, is right now tied up with organization of the General Assembly of IUPAP, and that was one of the reasons he could not make it. He sent his regrets, but he sent also a beautiful message, which I would like to read out. On behalf of the International Union of Pure and Applied Physics, IUPAP, I welcome you to the 37th International Cosmic Ray Conference. This conference is being organized under the auspices of the IUPAP Commission C4 on astroparticle physics. A major part of the mission of IUPAP is to foster international cooperation in physics. Sponsoring international conferences and assisting organizing committees are some of the ways that IUPAP carries out this part of its mission. And there is no better example of this than the large number of collaborations that characterize your field of cosmic rays. I'm happy to note that the C4 was one of the earliest commissions to be constituted by the IUPAP in 1947, and that the IUPAP has been sponsoring the ICRC from its very first edition in 1947. I would like to bring to your notice that in 2022, we would be celebrating the centenary of the formation of IUPAP. We have set up a special centenary committee to celebrate this event by hosting the Centenary Symposium next year in Geneva, as well as several satellite meetings that are being organized in different parts of the world. I invite you to take part in these celebrations, which incidentally would also coincide with the 75th anniversary of the C4. I do hope that despite its virtual nature, this conference will be a stimulating, informative, and enjoyable experience for all the participants. Signed by Michel Spiro. Over to you, Johannes.
Much, Sunil. Please convey our thanks to the President. And this concludes now our section with the welcome addresses. And we move on to the second big part of the agenda. This is messages from the C4 chair, the section with the awards and prizes, and the remembrance of Cosmic Ray community members that passed away in the past 2 years. For that part, I give over now the moderation to Sunil Gupta. Please, Sunil.
Thank you, Johannes. I would also like to extend a very warm welcome to all the participants in the 37th International Cosmic Ray Conference 2021, being held virtually from Berlin. Moving on, I would like to describe the IUPAP mission, which can be summarized in the following: to stimulate and promote international cooperation in physics, to foster free circulation of scientists, to foster the preparation and the publication of tables of physical constants, to promote international agreements on the use of symbols, units, nomenclature, and standards, to encourage research and education, to help in the application of physics towards solving problems of concern to humanity, to sponsor suitable international conference such as this one, and to assist the organizing committees. For this purpose, IUPAP brings out quarterly newsletters. An example of that is shown on the screen here. You can also access the newsletter at the IUPAP website. The IUPAP commissions are the backbone of the activities of IUPAP, and there are a total of 19 commissions. And what is of really relevance to us is the C4 Commission on Astroparticle Physics, which was earlier known as the Commission on Cosmic Rays. And as was mentioned in Michel's address, it was established by IUPAP in 1947 to promote the exchange of information and views among the members of the international scientific community in the general area of astroparticle physics. Now, astroparticle physics is a new emerging multidisciplinary field of research that deals with the study of particles coming from the universe. And it is divided into various themes, more traditional ones such as cosmic rays, gamma rays, solar and heliospheric physics, neutrinos, and dark matter. But this conference is seeing two new initiatives. There is brand new stream of multi-messenger physics, which Johannes mentioned in his opening remarks. And of course, there's an outreach and education committee, which was set up to deal with those issues. And those are also equally important because they deal with our interface with the society. Now, in addition to the commissions, IUPAP also has affiliated commissions. At present, there are 4 of them, and there are a number of working groups which are created and wound up as per the needs of the community. The mandate of C4 is to promote the exchange of information and views among the members of the international scientific community in the general area of cosmic ray physics, including the nature and characteristics of the electromagnetic, particle, and other radiation present in the cosmos, the theory and models concerning the origin of this radiation, non-accelerator high-energy physics, the specialized technologies necessary in the field, and their applications. The IUPAP C4 Commission gets constituted every 3 years during the IUPAP General Assembly, and the present commission began its work in the beginning of 2018 with a tenure up to end of last year. However, due to pandemic, its tenure was extended by 1 year, and at present it comprises of 14 elected members from 14 different nations, and it is also it comprises of 3 associate members who are selected on the basis of recommendations to the Executive Council of IUPAP. The ICRC can be described as the flagship conference, which is organized and supported by C4. Of course, this is not the only conference. There are other international conferences that are also supported by C4, such as TAUP, the topics on astroparticle and underground physics, IDM, ISVECRI, TEPA, VLVNT, etc. The topics, of course, are same, which I mentioned earlier, so I'm not going to go over them. But what has been a very welcome development in recent times is that the proceedings of all of the previous ICRCs are now available electronically on the ADS website of NASA, which is shown here. And it's also listed on a site in Netherlands. This work was made possible through the efforts of C4, especially Jorg Horrendel, our secretary. Now I would like to share some statistics on ICRC 2021. This, of course, unique feature is this is the first fully virtual ICRC. And I must congratulate our hosts, colleagues in local organizing committee who have done a phenomenal job, where the circumstances kept changing over the last 2 years, and so did the decision to have it from in-person conference to a hybrid conference to a virtual conference. So they ended up organizing essentially 3 conferences instead of 1. What is heartening is that the response has been overwhelming. We have nearly 1,700 registered delegates. Nearly 1,400 abstracts have been received, coming from 55 different countries. And the conference will also include 51 plenary talks, plus 1 public lecture known as HES lecture. The contributed talks will be presented during 5 parallel sessions. To assist this program, there were 8 international scientific program committees were set up by C4 in consultation with the local organizing committee, and they were tasked with the responsibility to recommend plenary topics, including speakers for the highlight, review, and rapporteur talks. Number 2, longer and shorter contributed presentations. And third, discussion sessions. In this virtual mode, since there is no room for asking questions in real time, so discussion sessions have been created where a group of people who are interested in a topic can meet and discuss those results that have been presented at the conference. And this is going to be the heart of the conference on this occasion. The International Scientific Program Committee, as was mentioned, there are 8 of them. The Committee on Gamma Ray Direct is headed by Luigi Tibaldo. Jim Hinton chairs Gamma Ray Indirect Committee. Elena Amato chairs the Cosmic Ray Direct Committee. Karl-Heinz Kampert chairs Cosmic Ray Indirect Committee. Subir Sarkar has chaired the Neutrino Committee. Ilya Ososkin has chaired the Solar and Heliospheric Committee. And Fiorenza Donato has chaired the Dark Matter Committee. And finally, the new stream, Multi-messenger Physics, that committee has been chaired by Michael Kachel-Rice. Now, they're of course very ably assisted by members whose names are listed below. And these 8 committees comprise of 56 members who are derived from 17 countries, making it a truly international endeavor. In addition, as Johannes mentioned, there is a committee on outreach and education chaired by Sabine Hammer and Carla Ramo. I would like to now mention the local organizing committee, which is very ably chaired by Johannes Knapp, co-chaired by David Berge. And then there is another 28 members who are drawn from all across Germany. And then I have only shown 3 pictures. The final one is of Julia Eckert. So all these people have played a phenomenal role. And I will give you a personal example that I had experienced. You see, till about a month back, I was in India, and I used to call them during hours that were convenient to me, and I would get instantaneous response from them. And about a month back, I came to the United States, and I called them according to time convenient for me, and they again respond in real time, instantaneously. So as a physicist, I can safely conclude they seem to be working 24 hours a day, 7 days a week. So it's all the outstanding work done by these 3 people and the rest of the members of LOC that we are having this very successful ICRC. On behalf of the participants and C4, I would like to thank the members of ISPCs and the local organizing committee for managing a very complex task so very efficiently. Well, now we come to the most awaited part of this program, and that is awards and prizes. So we have the following prizes to be awarded. IUPAP Locus Young Scientist Awards, there are 2 of them. Shakti P. Dugal Award. So these three awards, IUPAP Young Scientist and Shakti P. Duggal Award, these are meant for scientists who are relatively young. And then we have a Kelly Medal, the Youth Prize, the IUPAP TIFR Homi Bhabha Medal and Locust Prize, which is awarded to more senior scientists. And I must mention, being part of all these committees, that truly a number of exceptional nominations were received, and the task of the committee was very, very difficult. I would say it's not even selection, it was more of elimination. We really cannot award more than the number of prizes that are available, so we had to cut down some numbers. But I must say that they were all very, very outstanding people. Okay, so let's go on to the first IUPAP Young Scientist Award, which is meant to recognize the research by young scientists in a field of interest of the IUPAP C4 Commission. It is restricted to people with a maximum of 8 years of research experience after PhD. This award goes to Professor Carlos Arguelles Delgado of Harvard University, Cambridge, United States, for his fundamental, experimental, and phenomenological contributions to neutrino physics through the IceCube detector. Congratulations, Carlos. Now I have the privilege of inviting Professor Janet Conrad of MIT in United States to do the honor of reading the laudation of achievements of Carlos. Over to you, Janet.
Hi, I'm very honored to introduce Carlos Arguelles, who is receiving the IUPAP C4 Young Scientist Prize in Astroparticle Physics. Carlos was nominated for this prize by me, Aaron Vincent of Queen's University, and Francis Halzen of the University of Wisconsin. I know I speak for all of us when I say how happy we are that he's received this recognition. Carlos develops the theoretical basis for beyond standard model searches using astroparticle data, and then he performs many of those searches himself within the context of the IceCube experiment. He's a physicist who doesn't see a distinction between theory and experiment, nor does he see strong boundaries between astroparticle physics, particle physics, nuclear physics, and cosmology. So what I like to say is that Carlos is a physicist without borders. Carlos's journey to this prize began in Peru, where he received a master's in particle physics theory under the mentorship of Alberto Gago. He then went to the University of Wisconsin to study for a PhD under Francis Halzen. In this role, he had his first opportunity for experimental work, developing a search for sterile neutrinos in IceCube that leveraged the matter effects signature. My graduate student, Ben Jones, and I were excited to join this project, and it has turned out to be highly impactful. This paper from 2016 now has more than 250 citations. I was very pleased when Carlos accepted my offer as a postdoc at MIT. His role in my group has been to guide our group's IceCube analyses. He led our continuing searches for sterile neutrinos, as well as other beyond standard model physics. And at the same time, he was also one of a group of 6 from IceCube that were central to our first observation of the tau neutrino events. But Carlos had the creativity, the curiosity, and also the energy to do more than this. Early on in his career, Carlos recognized the IceCube data sets are very, very rich. And so during his postdoc, he set his mind to developing phenomenology that could provide grounding for analyses to really exploit this data set. To that end, during the last 5 years, Carlos has published 19 articles on beyond standard model phenomenology that is open to astroparticle experiments. And he has also published papers relating those results to particle physics experiments. Most of those papers have fewer than 10 authors, which is very unusual for someone who regards himself primarily as an experimentalist now. 4 of these papers have more than 50 citations already. 2 more of these papers are major reviews. One of them appears in Reviews of Modern Physics and the other in Physics Reports. His phenomenological work is appearing in Nature, in Physical Review Letters, and many other journals. So I think it is safe for me to say that he has had a very big impact in our field. In fact, this is a record that many advanced junior faculty would love to have. But Carlos is actually not very advanced in his career. He's only just begun as a faculty member. He has just completed his first year as a junior faculty at Harvard University. He went to Harvard in July 2020. And this has not been an easy year to become junior faculty, for sure. But Carlos has already assembled a dynamic group of young people to work with him. And he's constructed this group out of people who he's attracted from the theory community and from the experimental community, bringing together people who are postdocs and graduate students from both areas. So I'm all impressed that he is already growing a group that's the next generation of scientists that, like him, will believe that you don't have to have these borders. So with this, I would like to introduce Carlos Arguelles from Harvard University, the 2021 recipient of the IUPAP C4 Young Scientist Prize. Congratulations, Carlos.
Thank you, Janet. Now I have the distinct honor to present the IUPAP Young Scientist Award to Carlos. Carlos, the medal and certificate would arrive at your postal address in due course. And I'm happy to inform you that the award has already reached your bank account. Please check. I would now request Carlos to deliver his acceptance remarks. Carlos, over to you.
I am very excited and grateful to receive this prize. I want to thank my mentors Alberto, Francis, and Janet for their support and guidance through my academic career, as well as those who nominated me for this award and the ICRC committee for choosing me. I also want to thank all of my collaborators in this group experiments, especially my excellent co-analyzers, without whom this work would not be possible. I also want to thank my theory colleagues for engaging discussions and share enthusiasms in the search for physics beyond the standard model. It is easy to get pessimistic given that the LHC has found no sign of new physics at the TV scale. Direct detection experiments have seen no traces of dark matter and are running against the neutrino floor. And the fact that neutrinos misbehavior has proven extremely difficult to associate with a compelling beyond standard model explanation. I've witnessed a number of people that have become disheartened and discouraged in the search for new physics. I've even seen a number of brilliant students leave the field because they do not perceive a realistic possibility for discovery. But I've always been motivated by our continuous ingenuity in proving new physics, enabled by increasing our experimental reach in logarithmic and transformative new ways. As an example, we found that IceCube, a telescope that was never meant to be a particle physics experiment, has been able to make world-leading searches for stellar neutrinos, based on limits on dark matter, and improve the precision of unfailing neutrino oscillations, among others. These new ways are being pushed forward by a new generation of scientists who refuse to be discouraged by what appears to be a waning potential in traditional paradigms. I believe we have to support creativity, fight cynicism, and encourage the upcoming generation of physicists to pursue their ideas towards discovery by continuing to ask the important and fundamental questions about our universe in new ways. I'm confident that the discoveries that we seek will become a reality. I'm extremely happy to live in these exciting times, full of interesting measurements, observations, and questions to resolve. Additionally, I look forward to keep working towards a more diverse community that has a different ways of thinking, communicating, and probing the universe without boundaries between theory and experiments, between ethnic and cultural minorities and majorities. The sky is bright in neutrinos of all flavors.
Thank you, Carlos, and congratulations once again. Moving on, the next IUPAP Young Scientist Award goes to Dr. Francesca Calore of CNRS in France for her outstanding contributions to the phenomenology of dark matter. I have now the privilege of inviting my colleague in C4, Professor Fiorenza Donato from Torino University, to deliver the laudation for Francesca Calore. Congratulations, Francesca, and over to you, Fiorenza.
I'm very proud to present the reasons of my nomination of Francesca Calore for the 2021 IUPAP Young Scientist Award. Dr. Calore played a determinant role in the quickly developing field of multi-messenger astrophysics. The major achievements of her scientific career have been marked by her interdisciplinary work at the interface between theoretical physics, astrophysics, and astronomy. Her research activity focuses on particle dark matter phenomenology and its indirect searches, dealing with high-energy particle physics and high-energy astrophysics. In particular, she has developed models for dark matter annihilation into gamma rays, for the astrophysical backgrounds affecting dark matter searches, and the analysis of gamma ray data from the Fermi Large Area Telescope. She affirmed herself as a leader in the field thanks to her works on the Fermi GV axis towards the galactic center. She carried out one of the most relevant analyses of the Fermi GV axis data and advanced the state of the art on various fronts, especially for the characterization of multi-wavelength signatures from radio to even gravitational waves observations. Other works are related to the phenomenology of dark matter indirect detection in light of hydrodynamic cosmological simulations and galactic astrophysical uncertainties. She also discussed more exotic dark matter models, such as primordial black holes, deriving constraints from CMB, X-ray, and radio observations, and search for action-like particles in the spectra of Fermi-large galactic sources. She is the recipient of several research grants and leads now her own research group. Despite her young age, her track record in terms of papers, citations, presentations at international conferences, collaborators is simply impressive. Calore's papers are always deeply original and promptly become the state of the art. In scientific collaborations, she is a driving force and the project leader. She has the right strategic views and cares the competition with excellence as her guidance. I think that her scientific maturity is unique.
Thank you, Fiorenza. Now it is my honor to present the IUPAP Young Scientist Award to Francesca. Francesca, your certificate and medal will reach you at your postal address in due course. However, please check your bank account. The award should appear there. Now I would like to invite Francesca to deliver her acceptance remarks. Over to you, Francesca.
Good morning, everyone. I'm really honored to be among the recipients of the IUPAP Young Scientist Award. And I would like to thank all of you who have been supporting of my scientific career, starting from my PhD advisors, Thorsten Brinkmann and Fiorenza Donato, and all my fellow colleagues, such as Gianfranco Bertone, Christoph Wenninger, Pasquale Serpico, and Justin Ringt, among others. I would like especially to thank Tracy Slaters and Carlos Frank for supporting my nomination, and Fiorenza Donato for nominating me for this prize. I also acknowledge the funding from CNRS and the Agence Nationale de la Recherche, giving me the possibility to actually carry out my research and achieve my scientific objectives. And finally, I would like to thank my husband and children for their unconditional love and support.
Thank you, Francesca, and congratulations once again. Moving on to Shakti P. Duggal Award, which recognizes outstanding work by a young scientist in the field of cosmic ray physics, including astroparticle physics. The winner of this award is Professor Kay Fang of University of Wisconsin at Madison, USA, for her pioneering work in the field of neutrino astrophysics and gamma ray astronomy. Congratulations, Kay. Now I would like to invite Professor Martin Pohl of Potsdam University to deliver the laudation for Kay-Fang. Over to you, Martin.
It gives me great pleasure to introduce the winner of the Shakti Dougal Award 2021, Kay-Fang. It is unusual that a person is nominated twice, independently, by recent Shakti Dougal Award winner Abigail Firek with co-sponsor Angela Olinto, and by me and my co-sponsors Francis Halson and Jordan Goodman. But then, the unusual is quite usual for Kay-Fang. She did her PhD at the University of Chicago. As a JSI Fellow, she has worked for 3 years at the University of Maryland, followed by 2 years at Stanford University as NASA Reinstein Fellow. She is now a faculty member at the University of Wisconsin-Madison. Over the years, Kay-Fang has solidified her place as one of the most insightful astroparticle phenomenologists in the field. Her theoretical work is broad, creative, and important. Kay is a brilliant theorist whose work insightfully connects pieces together and builds bridges between theory, observation, and design of future experiments to make major advances in our understanding of the universe through the lens of multi-messenger astrophysics. The impact of her PhD work was quite exceptional. Studying the acceleration and interaction of particles at newly formed magnetized neutron stars that are still embedded in the enriched supernova material, Kay offered a natural explanation for the energy distribution of the chemical composition of cosmic rays at the highest energy. As an Einstein Fellow, she developed a code that permits following the spectral evolution and propagation of particles in a magnetized environment. Kay's simulations, published in Nature Physics, include the exceedingly important account for spatial variations within the system, which removes the artistic freedom of parameter choice that is inherent to numerous one-zone calculations and often the basis of overly optimistic claims. Kay-Fang's simulation package is the best that I have seen, and there are many potential applications. He is one of the very few scientists who combine deep theoretical analysis with an impressive understanding of observational data and their intricacies. Her careful thinking and tremendous technical skill are the basis of many quantitative predictions, for example, those on neutrino production at tidal disruption events, millisecond magnetars, and neutron star mergers. Her predictions of light curves and spectral behavior very much simplify the experimental search for and identification of such events. In fact, her new algorithm for the identification and localization of sources in IceCube data can find sources with far fewer events than was possible before. Kay was also instrumental in the detection with HAWK of multi-TeV gamma rays from SS433, an enigmatic microquasar. What impresses me most is that so many of her papers could carry a first ever stamp. She simply tries and accomplishes something new almost every time. Kay is already a leader in multi-messenger astroparticle physics, and I look forward to many years of her continuing to shape the field in major ways. Thank you.
Thank you, Martin. Now I have the pleasure of inviting Professor Jamie Holder of University of Delaware in United States to present the Shakti P. Dougal Award to Kay-Fang. Over to you, Jamie.
Good morning, everyone. I'm Jamie Holder. and as the chair of the Shakti P. Dugal Award Committee, it's my pleasure to introduce this year's award. Shakti Dugal was a fellow of the Bartle Research Institute who made important contributions to the field of solar and heliospheric cosmic ray physics. After Shakti Dugal's death in 1982 at the age of 50, his friends established a fund to provide an award in his honor. Given Shakti's long association with cosmic ray physics and his many contributions to the field during his career, the award is designed to recognize an outstanding young scientist for contributions in any branch of cosmic ray physics. The first Shakti P. Dugal Award was presented at the 19th International Cosmic Ray Conference at La Jolla in 1985. Awards have been made at 2-year intervals ever since, at each of the subsequent cosmic ray conferences, and the 18 past winners of the Dugal Award have all achieved recognition and prominence in their careers. The Dugal Award has achieved the status of the premier award in the field of cosmic ray physics, and the committee members are chosen to provide an international panel of respected leaders in the field that always includes one senior member of the Bartle Research Institute. The award consists of a $1,500 prize, a certificate, and an invitation to the winner to visit the Bartle Research Institute at the University of Delaware to present a colloquium and to discuss their work. This year's certificate will be presented in person to the winner during their visit to Bartle.
Thank you, Jamie. Now I would like to invite Kay Fang to deliver her acceptance remarks. Over to you, Kay.
I'm honored to be selected for this award. I want to thank the Shakti Dugal Award for recognizing the value of young researchers to the field of cosmic ray physics. I want to thank those who have been supportive of my career, my PhD supervisor, Angela Olento, my long-term collaborators, Kumiko Kotera, Kota Mulase, Brian Metzger, Roger Blanford, Eric Charles, and many other collaborators, as well as my students. I have been learning a lot from all of you. I want to thank the HAWK collaboration for their amazing discoveries of very high energy gamma rays. It has been a lot of fun working with you. And finally, I want to thank my family for their unconditional and continuous support. Thank you.
Thank you, Kay, and congratulations once again. Okay, now we move on to the senior category. The O'Kelly Medal recognizes significant contributions to the field of astroparticle physics over an extended career. And the winner of the award this year is Professor Paolo Lipari of University of Rome and INFN La Sapienza for his outstanding contributions to cosmic ray physics, including neutrinos, high energy interactions, and by making complex problems accessible to non-experts through pedagogy. Now I have the privilege of inviting my colleague on C4, Professor Ralph Engel of KIT in Karlsruhe, Germany, to do the honor of reading the laudation for Paolo. Over to you, Ralph.
It is a great pleasure to have Paolo Lipari receiving the O'Kelly Medal in recognition of his outstanding contributions to the field of astroparticle physics over an extended career. Paolo is well known for his contributions to our understanding of the production of neutrinos, in particular in the Earth's atmosphere, his works on neutrino oscillations, and lepton propagation. For example, his paper on lepton spectra in the Earth's atmosphere have become a classic that students read if they want to start in the field. The same applies to his work on muon propagation deep underground. Paolo's insight in the physics of neutrino production has also led to the first three-dimensional atmospheric neutrino flux calculations and has greatly helped to understand the observed effects. Paolo is one of the original authors of the hadronic interaction model Sybil. Sybil was the first interaction model in which modern high-energy physics concepts, including QCD-predicted mini-jet production, were implemented. Its different versions are used by generations of cosmic ray physicists since then for the simulation of cosmic ray interactions and, of course, for extensive air showers. In addition, Paolo has made important contributions to the phenomenology of hadronic interactions and corresponding air shower properties. One of the important aspects of Paolo's work is that he not only looks at particular questions of scientific importance, and he typically picks very hard ones, he also picks questions that are motivated by key scientific goals of experiments. And he also considers very critically the larger implications and the overall consistency with general concepts. His work on the relation and complementarity of neutrino and proton astronomy is a good example for this. Other examples include his work on cosmic ray propagation and the relation between positrons and antiproton fluxes in the galaxy, and his recent work on the interpretation of air shower data in terms of composition, hadronic interaction, and different source scenarios. Paolo has also worked on various topics of gamma ray physics and is also a member of the Agile collaboration. Here I only want to mention his work on the diffuse gamma ray flux and its absorption in the Milky Way. In short, Paolo has made key contributions to all fields of this conference. And he has always been very active, and as you all know, a very critical participant at workshops, conferences, and schools, stimulating progress in the field. Let me close by mentioning Paolo's passionate and tireless work to give lectures at schools on astroparticle physics. Most of the young people here at the conference have already listened to one of his very enthusiastic lectures, inspiring generations of young scientists in their work. Paolo has traveled all over the world to deliver lectures, and he is known for his commitment to support science also in countries with limited resources. Please join me today in congratulating Paolo Lipari to receiving the O'Kelly Medal 2021.
Thank you, Ralph. I would now like to invite Professor Luke Drury at Dublin Institute of Advanced Studies in Ireland to present the O'Kelly Medal to Paolo Lipari. Over to you, Luke.
On behalf of the Dublin Institute for Advanced Studies and the three daughters of the late Professor Cormac O'Kelly, who jointly sponsored this award, it is my great pleasure to introduce this year's O'Kelly Medal. This award is given by the Astroparticle Physics Commission itself for distinguished contributions to cosmic ray physics extending over a long career. It commemorates the late Professor Cormac O'Kelly, who worked with Pierre Auger in Paris, with Lord Rutherford in the Cavendish, most productively perhaps with Menon and Powell in Bristol, and was a character well known to all the early great cosmic ray physicists. He did important early work on meson physics, including kaons, and perhaps most importantly, he established that in the decay mode of the pion, a neutrino is emitted. He was the head of the cosmic ray section in the School of Cosmic Physics in the Dublin Institute for Advanced Studies from 1953 to 1982. Here is a sketch of him as a young man in the Cavendish laboratory under Rutherford, which forms the basis for the profile on the front of the medal. And here is the dedication on the reverse to this year's recipient. Congratulations, Paolo Lipari, O'Kelly Medalist 2021.
Thank you, Luke. Now I have the privilege of inviting Paolo Lipari to deliver his acceptance remarks. Over to you, Paolo.
Well, hello to everybody. So what can I say? I'm really very glad, I'm very honored for this prize. I must say that I'm also sincerely embarrassed. I think that there are many people, many colleagues that would deserve this more than me. But anyway, I have a very high opinion of the colleagues that nominated me. And so I'm glad that they could think about me for this, just consider me for this. And well, anyway, if I think why is there a reason for thinking about me, is that I think I've been very passionate, very enthusiastic about cosmic ray and high energy astrophysics for a long time. I started as a particle physicist, and I think it was more than 35 years ago. In Italy, they were building the Gran Sasso laboratory, and so there was people started to get interested in in cosmic rays, in the possibility of seeing neutrino underground, and so on. So I joined Macro. Barry Barish and Giorgio Giacomelli were the spokesperson. Actually, Tom Geiser at the time was visiting Italy, was discussing with the people who were building the laboratory, and was a very important encounter for me. He invited me in Bartol. There I met Todo Stanev. I actually met also Ralph Engel there. There was a Belgian colleague from Wisconsin, Francis Halsen, was telling strange ideas about putting photomultipliers in under ice. And so it was wonderful to follow for these decades the development of high-energy astrophysics. I learned to appreciate people building detector in space, in the Pampa of Argentina, the South Pole, and the theorists trying to understand what they were discovering and trying to develop the things has been a wonderful time. I try to be broad in my interests, but it's more than it's not that I tried. I think it was inevitable. To understand the high energy universe, you have to look at this in very different ways. That's why we do multi-messenger astrophysics. So there is neutrino physics, gamma astronomy, cosmic rays, of course, are very important, obviously, and we are now trying to learn about general relativity, formation of black holes, and you have to go broad in energy. I think we still want to understand well solar modulation at 1 GeV, and then the ultra energy cosmic rays at 10 to the 20 electron volts. So this is a fantastic field, and for the young people, I think there is a lot of things we don't understand. There are a lot of things to discover. So I'm still very enthusiastic. And by the way, I still like particle physics. I think there are deep connections that we have to maintain and develop. I'm talking too long, but I have to add one thing. I'm really sorry not to be in Berlin and not to see you in person. I really would like to say my words of appreciation, well, for Sunil Gupta, who has been a fantastic chairman of the SC4 committee, and for Johannes Knapp, who has been a chairman of this, organizing this conference in these difficult circumstances. I know that they have been thinking for a long time, when actually it was not clear, 1 year ago, what would happen at this time. And this has been a very difficult time. I hope you and your family have not suffered too much from this. And I think in this difficult year, we learn to try to do things in a different way. And this is actually, when you do things in a different way, you learn to do them better. I think the successful participation of the ICRC has been really remarkable. And this organizing things in these circumstances is an occasion to learn to do things better. And I sincerely hope, and I'm actually confident, that doing things in this difficult way will be an occasion to learn to communicate better. And communicating better is also doing science better. And so my best wishes for all of you for a successful meeting, for learning for fully exploring this occasion, and for continuing to study this wonderful field together. And so, okay, again, thanks again. I think I don't deserve it, but I'm really happy. Thanks again.
Thank you, Paolo. But this is where I will depart from the script and say, as head of the jury, that you were indeed the most deserving candidate. We wouldn't have it any other way. So congratulations, Paolo. We now move on to the Youth Prize, which recognizes a scientist whose research career has made substantial contributions to the understanding in the field of cosmic rays. The research should have had a major impact in the field. And the winner of this award is Professor Anthony Bell of University of Oxford in UK for his outstanding contributions to the understanding of the acceleration of cosmic rays through turbulent magnetic field amplification. Congratulations, Tony. And I would now like to invite my colleague, Professor Steve Barwick of University of California, Irvine in USA, to read the laudation and present the Yod Prize to Tony Bell. Over to you, Steve.
A little over 2 years ago, our community lost a giant with legendary vision and great compassion. Garang Yod and his wife Kamal were keenly aware that many of his colleagues were doing great work, but not getting enough recognition for it. To improve this situation, he and Kamal endowed a new prize for lifetime achievement in the understanding of cosmic rays, broadly defined. Since the awarding of the first Yod Prize in 2001 to Dr. Reuven Ramadi of the Goddard Space Flight Center, it's become one of the most prestigious honors in our field. And I'm grateful for the International Committee of Distinguished Scientists and particle astrophysicists that worked hard to select today's awardee. And despite a few difficulties imposed by the pandemic, working with this committee has been a truly rewarding experience for me. So I'm very proud to announce this year's Yod Prize recipient is Professor Anthony Raymond Bell, Tony. Some of you may remember his masterclass and lecture at the 2013 ICRC in Rio de Janeiro. The topic covered cosmic ray acceleration by shocks and supernova remnants. So Tony's career has straddled both cosmic ray physics and electron transport and laser-produced plasmas. So I want to highlight two achievements that together demonstrate his critical contributions to the development of the standard model of cosmic ray origins. The theory of diffusive shock acceleration was proposed in the late 1970s by Bell, independently by several other groups. But the theory of turbulent magnetic amplification, magnetic field amplification, was proposed by him alone. Both contributions provide overwhelming evidence for the impact of Tony's work on our field. Diffusive shock acceleration is a first-order Fermi acceleration in the presence of strong shock waves. I recall following Bell's physical approach to this physics process as a graduate student. It was featured in a popular book by Longair, and I used it in my own course on high-energy astrophysics. Tony's theory is intuitive and extremely robust, at least for non-relativistic shocks. Works well for all kinds of sources, from solar flares to structure formation shocks in galaxy clusters. The calculated energy spectrum of accelerated particles was a power law index of -2, which is actually commensurate with the typical spectral index of synchrotron radiation from supernova remnants. That was an important clue. Tony realized that while the spectrum of accelerated particles was universal, the rate of acceleration depended on the ability of cosmic rays to generate magnetic turbulence ahead of the shock. More turbulence can scatter the particles and quickly redirect them back to the shock for further acceleration. You need to cross the shock many times to get to the energies of cosmic rays. So Tony identified a previously unknown, non-resident plasma instability, commonly called Bell's instability, that amplifies magnetic fields upstream of the shock. This mechanism provides a credible path to reach 10 to the 15 electron volts. And you can get to those energies in supernova remnants. One member of the Yod committee explained, without him, we would still wonder how we get cosmic rays above 10 to the 13 electron volts. Well, on behalf of the Yod Prize Committee, I asked Tony to accept the Yod Prize Award, virtually, of course. The inscription on the plaque reads, "His theoretical contributions led to a breakthrough in the understanding of acceleration of cosmic rays by amplified magnetic fields." Congratulations, Tony.
Thank you, Steve. Now I have the privilege of inviting Tony to deliver his acceptance remark. Over to you, Tony.
That's very kind, thank you. I started working on cosmic rays 46 years ago. In these years, the subject has advanced enormously. It's a long journey, and we're still far from the end of the road. But now is a good time to be in the subject, with lots of new data coming through and the promise of more to come. I count it a privilege to be part of this endeavour. I thank you for this recognition, and I look forward to all that we, or you, will learn in the next few years. Thank you again.
Thank you, Tony, and congratulations once again. Okay, now we go to the final award, and that is Homi Bhabha Medal and Prize, which is given to an active scientist who has made distinguished contributions in the field of high-energy cosmic ray physics and astroparticle physics over an extended career. The winner of the award on this occasion is Professor Francis Halzen of University of Wisconsin at Madison in United States for his outstanding contributions to cosmic ray physics, including high-energy neutrino physics through the IceCube detector. Congratulations, Francis. Now I have the privilege of inviting Professor Subir Sarkar of Oxford University in UK to do the honor of reading the laudation. Over to you, Subir.
It is our great pleasure to honor Francis Halzen, who is Hildel and Gregory Bright Professor at the University of Wisconsin-Madison and the Principal Investigator of IceCube, with the award of the 2021 TIFR IUPAP Homi Bhabha Medal and Prize for his contributions to cosmic ray physics. Francis is a distinguished particle phenomenologist whose research career spans over half a century. In 1988, he proposed a technique for gradually developing a neutrino telescope in a location and a medium that is attractive from the physics point of view and is also cost-effective compared to alternative proposals. This was realized in 1993-94 with the construction of the Antarctic muon and neutrino detection array, which deployed 80 photomultiplier tubes on 4 so-called strings at a depth between 810 and 1,000 meters in the polar ice cap to detect the Cherenkov light of high-energy cosmic muons traversing optically clear deep ice. However, the light scattering length, even at that depth, turned out to be too short to allow any tracking or useful detection volume. Nevertheless, Francis and his colleagues persevered. The follow-up experiment IceCube deployed 86 strings by 2010-11, each carrying 60 photomultiplier tubes spread at depths of 1.5 to 2.5 kilometers and spread over 1 square kilometers, thus instrumenting an entire cubic kilometer of ice. Using this fantastic instrument in 2013, the IceCube collaboration obtained the first evidence for high-energy neutrinos of cosmic origin. This was followed up in 2018 with the identification by IceCube of the first astrophysical source of high-energy neutrinos, a supermassive black hole in a blazar about 6 billion light years away. This was a demonstration of multi-messenger astronomy, exploiting coincident measurements of neutrinos and gamma rays. In order to have created neutrinos with the observed energies of several hundred TeV, this object must be among the long-sought astrophysical accelerators of ultra-energy cosmic rays. This breakthrough was recognized by the award of the 2021 Bruno Rossi Prize of the American Astronomical Society to Francis Halzen and the IceCube collaboration for the discovery of a high-energy neutrino flux of astrophysical origin. Although this discovery was made by a large collaboration of scientists and engineers, Francis, who has led this effort over the past 30 years, was singled out for particular credit. Unusually, he is a theorist by training. Indeed, he has also been at the forefront of interpreting the observations in terms of astrophysical models. He can thus be said to have made significant contributions to both the theory and experiment, which have opened up a new window on the universe, while also beginning to answer the century-old riddle of the origin of cosmic rays. I might add that he is also a wonderful teacher and colleague who always makes himself available to guide young researchers and mentored the next generation of scientists. There is, in fact, an interesting parallel to Homi Jahangir Bhabha, in whose memory this award is made. Bhabha, too, was a theorist, but it was he who initiated the experimental research program on cosmic rays in India. Atmospheric neutrinos were, in fact, first detected in TIFR's underground laboratory in the Kolar gold fields. So it is particularly appropriate for this prestigious award to be made to someone who embodies the same rare quality of being an all-around physicist. Please join me in congratulating Francis Halzen upon the award of the 2021 TIFR IUPAP Homi Bhabha Medal and Prize.
Thank you, Subir. Now I have the distinct honor of presenting the Homi Bhabha Medal and Prize to Francis Halzen. But first, I would like to read a message from Professor Ramakrishnan, Director TIFR. The Bhabha Medal and Prize commemorates Dr. Homi J. Bhabha, the founding director of the Tata Institute of Fundamental Research, TIFR, who had made pioneering contributions to the area of cosmic ray research in India and initiated experimental work in this area at TIFR. As part of the birth centenary of Dr. Bhabha, the TIFR and the IUPAP C4 Commission had created the Homi Bhabha Medal and Prize in 2010 to recognize outstanding research in this area of science. And the first prize was awarded during the 32nd ICRC in Beijing in 2011. We are delighted to note that Professor Francis Halzen of the University of Wisconsin at Medicine in USA has been awarded the Bhabha Medal and Prize for outstanding work on cosmic rays, neutrinos with the IceCube detector, and that he would receive this award during the 37th ICRC in Berlin. I take this opportunity to invite him to visit India once the pandemic is over, and we look forward to his visit and public lectures at TIFR Mumbai and the Cosmic Ray Laboratory in Ooty. Here is the certificate for 2021 TIFR IUPAP Homi Bhabha Medal and Locus Prize, which will reach Francis at his postal address, along with the medal in due course. And Francis, you should check your bank account. The award should appear there. Now, I have the pleasure of inviting Francis Halzen to deliver his acceptance remarks. Over to you, Francis.
I thank the members of the IUPAP C4 Commission and Professor Sunil Gupta for this award. When Professor Gupta sent me an email a couple of weeks ago announcing that I received the award, I got very excited. And I wrote back to him, I can finally conclude that I became a cosmic ray physicist. Let me make clear, I am very proud of having paid attention to cosmic ray physics long before the research was joined by many particle physicists and became particle astrophysics. If I made contributions, it's because I ran into incredible collaborators who were the leaders in the field and still are. My ultimate collaborators, of course, I found within the Amanda collaboration and now IceCube, who made high-energy neutrinos part of the high-energy cosmic ray spectrum. We overcame two huge gambles. One was that deep Antarctic ice would actually be able to perform as a Cherenkov detector. The second was that the detector we built would be big enough to see any signal. I would like to thank the NSF for having shown the courage to underwrite these great adventures. So thanks to everybody and thanks to IceCube. This prize is shared with all of you. Thanks.
Thank you, Francis, and congratulations once again. Now, since this concludes the award events, how wonderful it would be if we could see all 6 winners in a single frame. But I guess it's a bit late for that. Well, oh, that's amazing. Thanks to our colleagues in LOC for performing that magic. Okay, we now move on to the most solemn part of this event. Many of our colleagues have made immense contributions to our field and enriched our lives as mentors and friends, but are no longer with us. We remember those that we have lost in the past 2 years, and unfortunately, some of them to COVID.
background music was a rendition of a non-denominational prayer by Mahatma Gandhi by late Professor Gaurang Yod on sitar, of which he was an exponent, besides being an exceptional physicist, teacher, and mentor to many of us. It is a poignant moment, as so many of these stalwarts have been my mentors as well. And it's hard to say goodbye to people you have always been with and have always looked up to. As we all know, that the ICRC 2021, which is the 37th edition, is being held virtually because of the pandemic. But as Johannes mentioned in his opening remarks, that there are certain benefits as well. And I guess we have lots of lessons to learn from this particular experience. So I would request you during the conference, please see what are the features that you liked, what are the aspects that were more helpful to you, and those which were not helpful. And give us feedback. We will circulate a questionnaire during the conference, which we will, with the help of LOC, would pass on this feedback to the organizers of ICRC 2023, which will be held in Osaka. Of course, the LOC in Osaka would make a final call as to how to implement these changes. Now we come to the concluding slide, and this is a view of the Daisy Zeuthen site. And you can see the black roof, which is essentially the ICRC mission control, where our colleagues from Daisy are working around the clock to make this virtual conference happen. It's an unfortunate outcome that we have missed out on meeting in person because of pandemic, but I think they have made it up to a large extent by putting in a lot of hard work. Now, this brings me back that the last time Germany had organized an ICRC was in 2001, which was the 27th edition in Hamburg, near another campus of Daisy. And but that time, there were no tools available for a virtual conference. So we are lucky that pandemic didn't happen then, because then one would have canceled it. But having learned those lessons, I think we can use it for greater benefit. Once again, I welcome you to 37th ICRC. And with this, I declare the 37th ICRC in 2021 open. Thank you very much. Please enjoy the conference. And now over to Johannes for announcements.
So thank you very much, Sunil. It's great that the conference has been opened now. I just have to say, we start with the science program in about 45 minutes. You can have a coffee break now. We all here jump into the river behind us to get a cool bath, and then we see us back in the first plenary highlight session in 45 minutes. Thank you very much. Welcome to the conference, and see you soon.